Jamb must repeat question 7 based on popular demands. A lot of candidates has been begging I explain the answer to this question so they understand in the simplest form, like I always do. I'm a good guy, I will teach you, I will explain everything to you. The question reads, the group 8 elements are the inert gases because they dash. A. Have lone pair of electrons on their valence shell. B. All have completely filled valence shells. C. Are all solids. D. Are all polyatomic molecules. Let's find out the answer. I will not only teach you how to identify this answer, but how to identify any question at all from periodic table. Any question you see from periodic table, and I'm also going to cover chemical bonding in this same video. So do well to get your pen and your paper to write down, because here we don't use textbook. I don't stress students. I don't want stress. I don't like stress, and I don't stress students. I assist you in scoring your 300 plus in Jamb UTME without suffering yourself, stressing yourself reading textbook. So get your pen and your paper and jot down, because you are going to use it for subsequent revision, maybe 3 weeks to your Jamb UTME. You bring all the notes you've made and use it to revise and prepare for your Jamb UTME, getting yourself 100% fortified for the exam. Let's go. We have to understand the periodic table and everything about the periodic table. In the periodic table, we have various groups and various periods in the periodic table. We are going to understand periodicity. We are going to understand the periodic table. But first of all, let's deal with the group. Features of each group in the periodic table. Each of the group found in the periodic table, we are looking at their features. How do you know them? What are their features? What are their characteristics? The members of those groups. We have to figure that out now. The first we have here is the group 1. And the group 1 elements, take note of the color coding. This is color coded in blue. And they are called, the group 1 elements are called the alkali metals. They are called the alkali metals. And why are they called alkali metals? Do you have an idea of that? I am going to tell you because I'm a good guy. They are called alkali metals because when they dissolve in water, they form an alkali. So when they dissolve in water, they form alkali. That's why they are called alkali metals. And the members of group 1 involve lithium, sodium, potassium, rubidium, and so on and so forth. These are the common members of the group 1 of the periodic table. And what are their features? We already stated that they are called the alkali metals. They were given that name because they dissolve in water to form alkali. Okay, so the first we have here under their characteristic is most reactive metals. The alkali metals are the most reactive metals. The group 1 metals are the most reactive metals. The second here is have one valence electron. They have one electron in their outermost shell. You know what a valence electron is? The amount of electron in the outermost shell of an atom. So they have one electron. All of them, lithium, sodium, potassium, ruby, all of them for that group, they have one what? Only one electron in the outermost shell. The next feature here is form +1 ions. They form +1 ion. You can see sodium positively charged, only 1 ion. Potassium positively charged, only 1 ion. Lithium positively charged, only 1 ion. It's very electropositive, and electropositivity increase down the group. So as you go down the group, their electropositivity increases. As you go down the group, the electropositivity increases. So that's that for that. So as you go down the group, electropositivity increase. That means the one up will be less electropositive than the one you have below. As you go, electropositivity increases as you go. So the final we have here is stored under oil because they are very reactive. They react violently. So they react violently with water to form alkali, like I said. That's why they are stored under oil, to preserve their purity. To preserve their purity, they store them under oil. So other features we have here, we have other features we state form strong alkali, such as sodium hydroxide and potassium hydroxide. Okay, another one here says soft. They have low melting points. They are soft metals, very soft, and they have low melting points. And melting points decrease down the group. So as you go down the group, melting points decreases. The next we have here is react with water to liberate hydrogen gas and form metal hydroxide. And you know what an alkali is? A basic hydroxide that dissolves in water. So that's why they are called the alkali metal. So they react with water readily to form hydrogen gas as a byproduct, and in the process yielding metallic hydroxide. The next we have here is show flame color. They usually have a flame color. We already treated flame colors of metals and gases. Okay, so do well to take that lecture if you haven't taken that lecture. So there are flame colors, for example, like sodium yellow flame color, and for potassium lilac flame color. So you have lithium with crimson flame color, and so on and so forth. They normally have their specific colors of the flames when they burn. Let's move over to the group 2 element in the periodic table. Yeah, right there. Under the group 2 element of the periodic table, group 2 elements are also called the alkali earth metals. Take note of the color coding. So they include beryllium, magnesium, calcium, and so on and so forth. So what are their features? First of all, do you know why they are called the alkaline earth metals? Do you know? I don't think you know, but if you know, that's good for you. But if you don't know, for those who don't know, let me explain why they are called the alkaline earth metals. They are called the alkaline earth metals because they are extracted by roasting their alkaline ores. That's how they are extracted from the earth. Okay, roasting their ores. That's how they are extracted. And their features include 2 valence electrons. Remember, group 1 element has what? 1 valence electron. That's why they are also called group 1 elements. Group 2 element has what? 2 valence electron. So as is going to be group 3, group 4, group 5, group 6. That's just a common feature. The name of the group goes with the number of valence electrons, or rather the numbers of the valence electrons helps in naming the group. So if the valence electron is 2, such elements will belong to the group 2. If the valence electron is 3, such elements will belong to group 3, and so on and so forth. That's it. So the next here is they form +2 ion. So if the valence electron is 2, that shows the ion will be +2, definitely. Less reactive than the group 1. So after the group 1 elements, the group 2 elements are the more reactive metal. That's where you find the metal, the second in command, according to reactivity, from the group 2 metals. So after the group 1 metals, which are the most reactive, then the group 2 metals come second in command. And the next we have here is react with cold water mildly. Okay, they react mildly with cold water, what they call mildly. Okay, they react mildly with cold water. For example, magnesium reacts with steam, only steam. Okay, magnesium can only react sparingly with cold water. They form basic oxides such as magnesium oxide and calcium oxide. Yes, you know, they are impure forms. They appear in oxides, and these oxides are alkaline. They are bases. They are alkaline. Okay, you know, alkaline is a basic hydroxide. And these forms are an alkali solution. They are alkalinic. Okay, they are basic. So that's why they are named alkali earth metal, because you roast this oxide to extract them. You extract them and you get a more pure form. It's higher melting points than group 1. Remember, group 1 elements are soft metals, so they have lower melting points. So the group 2 elements, they have higher melting points than the group 1 elements. The next we have here is produce white ionic compound. They produce white ionic compound. So when they are in their ionic form, the compound is usually whitish in color. Moving on. Now let's look at group 3 elements. Group 3 elements, under group 3 elements, they are called the boron group, or you can call them the boron family. Okay, because the boron is the first element there. They just use boron to name all of them. So you can say boron family or boron group. And the members of that group includes the boron, aluminium, and so on and so forth. What is the first feature we have under the boron group? Group 3, they have 3 valence electron, as you all know. So you can use the valence electron to know the group that an element belongs to. So just draw the orbital diagram, figure out the valence electron, and you are there. They form +3 ion. Definitely, they form +3 ion because they are group 3 elements. Their valence electron is 3. Boron is a metalloid, while others are metal. So in this group, there is something peculiar. Boron is a metalloid, while others are metal. You know what metalloids are? Metalloids are elements that shows both the property of metals and non-metals. So that's a metalloid. The next we have here is aluminium forms amphoteric oxide / hydroxide. So aluminium is the only member in this group, group 3, the boron group, that forms an amphoteric oxide and hydroxide. Next feature we have here is compounds are mostly covalent for B, and that's for boron, and ionic for others. So any compound that they are forming, if boron is involved in the compound, just know that the compound is going to be covalent. Remember, boron is a metalloid. It can serve as a non-metal. For the rest, it's ionic bond. That's what they usually form. Let's move on to the next group, group 4. All right, group 4 elements are called the carbon group or the carbon family. And the members of this group include carbon, silicon, germanium, tin, lead, and so on and so forth. So, and you know that if they belong to group 4, meaning they should have 4 valence electron in their outermost shell. That's it. So they have 4 valence electron in their outermost shell. You remember that inserting elements into groups, we use valence electron to insert elements into the group. That's what the periodic table chemists did when they were creating the periodic table. They used the valence electron to place elements in various groups. Carbon and silicon are non-metal / metalloid, respectively. So carbon is a non-metal, while silicon is a metalloid. Tin and lead are metals. Yes, they are metals. They show variable oxidation state. They don't have one oxidation state, unlike group 1 to 3. They just have one oxidation state. All this one, they have variable. Their oxidation state varies from +2 to +4. They form both covalent and ionic compound. Yes, because you have non-metal there, you have metal there. The final we have here is carbon dioxide and silicon dioxide are acidic oxide. Yes, they dissolve in water to form acid. If dissolve in water to form acidic solution, they are like anhydride. They are like acid anhydride. Moving on to the next group, group 5. Group 5 elements, they are also called the nitrogen group or the nitrogen family. Why? Because nitrogen is the first element in the group. So the group is named after nitrogen. So what are the members of the group? We have nitrogen, we have phosphorus, and so on and so forth. What are the facts about this group? Group 5 elements, they have 5 valence electrons. Of course, you know, elements are placed in the group according to their valence electron. So they are group 5 elements, so that tells you they have 5 valence electrons in their outermost shell. Okay, or electrons in the outermost shell, valence electron. They show oxidation of -3 + 3 + 5. -3 + 3 + 5. Nitrogen is very stable. Triple bond. You know the shape of nitrogen molecule. It's a triple bonded molecule. So their oxide varies from acidic to amphoteric to basic. Okay, they form acidic. Just know that they form acidic oxide, they form amphoteric oxide, they form basic oxide. So now you have two groups where you have elements that form amphoteric oxide. You have the group here, you have aluminium, which is the group 3, and you also have the group 5. So they form covalent compounds because you have mostly non-metals here. That's what you have, mostly non-metals. Okay, but they form covalent compound. Moving on to group 6. Group 6 elements are known as the chalcogens. They are called what? The chalcogens. The first element there in group 6 is oxygen. Why are they group 6 element? They are group 6 element because they have 6 electrons in their outermost shell, or they have 6 valence electrons. And the members are, you have oxygen, you have sulfur, you have selenium, you have polonium, and so on and so forth. Their oxidation state is -2 + 4 and +6. Each of the elements has one of these oxidation states. Okay, so oxygen is a very electronegative element under this group. So oxygen is very electronegative, and they form acidic oxides. They form acidic oxides such as sulfur oxide and sulfur 6 oxide. They react with hydrogen to form water and hydrogen sulfide. They react with hydrogen to form water and hydrogen sulfide. Okay, so sulfur reacts with hydrogen to form hydrogen sulfide. Oxygen reacts with hydrogen to form water, and so on and so forth. Moving on to group 7 elements. Group 7 elements are also called the halogens. You can see it's color-coded with red. It shows you they are very reactive, very electronegative. They have high affinity for electrons. They are powerful oxidizing agents. Under the group, you have fluorine, you have chlorine, you have bromine, you have iodine, and so on and so forth. They are the most reactive non-metals, okay, and they have 7 electrons in their outermost shell, 7 valence electrons. Okay, they exist as diatomic molecules, such as F2, which is fluorine, molecule of fluorine, chlorine, molecule of chlorine. Iodine itself is also I2, bromine is also I2, and so on and so forth. The next we have here is they form -1 ion, which are called their halides. For example, F-1, that's a halide. Halide is just like sulfide, halide, and so on and so forth. So the halide is a common name for all the halogens. So when you have fluoride, for example, hydrogen fluoride, that's a halide, but the specific halide is fluorine. When you have hydrogen chloride, that's a halide, but the specific halide you have there is chloride. So as bromine, iodine, and all. You can have hydrogen iodide, you can have hydrogen bromide, and so on and so forth. Then the final we have here is react with metals to form salt. They react with metals to form salt. That's very common. The halogen also has more property or more features. Let's look at them. Reactivity decreases down the group. Reactivity, as you go down the group, the reactivity of the halogens decreases. So you are going to find the most reactive at the top, and you find the least reactive at the bottom of the group. So they are strong oxidizing agent, like I said before, and oxidation strength reduces down the group. So as reactivity reduces as you go down the group, so as oxidation strength is going to decrease down the group. They form displacement reaction. They form what? Displacement reaction. What is displacement reaction? A displacement reaction is a reaction whereby a highly electropositive element displaces a least electropositive element from their compound or from their salt. So it removes that element from that position. So that position that element occupied there, a halogen is going to displace it. It's going to pull it out from that position and replace it there. That's a displacement. It displaces it and it assumes the position of the elements. They sit there, and because they are superior in terms of electronegativity. For example, chlorine displaces bromine, iodine. Why does chlorine displace bromine and iodine? Because chlorine is more electronegative, chlorine is more powerful, chlorine is a stronger oxidizing agent than both of them. So on the other hand, bromine is going to displace iodine because bromine is more, so that's what you are seeing here. Bromine displaces iodine, iodine displaces none because iodine is the least reactive under the halogens. Moving over to group 8. Group 8 elements. And what are the group 8 elements? They can also be called group 18 elements in modern periodic table, and they are also called group 0 in older periodic tables. So they are referred to as the noble gases, or they can be called rare gases. Okay, but they are commonly called noble gases. They include helium, neon, argon, krypton, xenon, and so on and so forth. What are their features? They are inert and unreactive gases. They are mainly gases. They are inert and unreactive. They are stable. Okay, they've achieved octet or duplet stability. Apart from helium, the rest elements in this group achieves what they call the octet stability, while helium achieves duplet stability. So they have full valence shell. They are stable, so they have completely filled valence shell. They have no electron to donate and they can't receive electron. Everything full, everywhere is full. So they are monoatomic gases. They have very low boiling point and they do not form compound easily, except xenon and krypton forming some fluorides. Very difficult for them because they are stable, they are inert, they are unreactive. So the final we have here is they are used in bulbs, lasers, and balloon. You use helium gas for balloons, and they are also used for cooling. Helium gas can be used for cooling in machines, especially machines that are used in the medical diagnostic sector, such as the MRI machine, where you use the helium gas to cool the components. So let's move on to transition elements or transition metals. Transition metals, they occupy the middle part of the periodic table. Okay, that middle part of the periodic table, that's the area in the periodic table that is left for transition metal. And you know what transition metal are? They are metals that are discovered later after the periodic table has been designed. So they just left that space for them so that any new metal that are coming, they are going to place them there according to their atomic number that are projecting at when they were discovered or when they were uncovered. So the first feature we have for the transition metal is that they form colored ions and compounds. Very colorful. They form complex ions, compounds. The second feature is they show variable oxidation states. They don't have one oxidation state, different oxidation states. They act as catalysts. That's true. Yes, that's what they are mostly used as catalysts. Okay, they form complex ions. When you hear colored ions, just know that they are complex ions. They exhibit paramagnetism. They are used as paramagnets, especially in coils, in alternators, electromagnetic induction, in transformers, and so on and so forth. They form alloys easily. They are used in making alloys. Very common. So these are the features of transition metals. Let's look at the lanthanide. The lanthanides. What are the lanthanides? The lanthanides are elements which have the atomic number from atomic number 58 to 71. They are rare earth metals. That is their common name. They are called the rare earth metals. They are rare in the earth crust. Very difficult to find, very difficult to sort. They form +3 ions. That's one truth about them. They have similar chemical properties. Okay, they are just like the halogen, which have similar chemical properties. So they are used in magnets and electronics. That's where you use the rare earth metal or the lanthanides. That's what you use them for. So those elements from group 58 to group 71 are the lanthanides. So let's look at the actinides. The actinides are the elements of the atomic number from 90 to 103. They are 14 in number. And what are the actinides known for? They are known for radioactivity. They are radioactive elements. Very radioactive. They mostly occur in +3 and +4 oxidation states, and they are used in nuclear energy. So as you hear radioactive, so just know that it's nuclear energy now, making of nuclear weapon, nuclear bomb, nuclear energy, nuclear power, nuclear electricity, and so on and so forth. Now let's look at the Jamb concentration in the periodic table. What Jamb normally sets in the periodic table, and the facts you need to know as regard the periodic table. Jamb main concentration in periodic table. Group 1, they are the most reactive metals. Know that, have that in your head. Group 7, most reactive non-metals. Group 8, they are unreactive, they are stable. They have completely filled outermost shell or valence shell. Then the transition metal, they are known for what? Colored ions. They form catalysts, they form complex ions. They have variable valencies. And one more thing about them, about the transition metal, they have completely filled D block. They have completely filled D block in the subshell level. Take that down. Completely filled D block. That's one feature of the transition metals. Okay. Then aluminium is amphoteric. Remember another group that also form amphoteric. The group 6. They also form amphoteric oxide. Okay. Aluminium forms amphoteric oxide. Halogens reactivity decreases down the group. The reactivity of halogens, it decreases down the group. Alkali metals reactivity decrease down the group. So alkali metal, their reactivity also decreases as you go down the group. So let's look at the trends in the periodic table. The trends in the periodic table is also called the periodicity. Okay, so if they ask you to define periodicity, just say the trends across every part of the periodic table. That's periodicity. So let's look at what periodicity is according to the statement we have here. Periodicity refers to the repeating pattern of physical and chemical properties of elements when arranged in order of increasing atomic number in the periodic table. So it's talking about the repetitive, both physical and chemical properties of elements in the periodic table. Okay, repetitive. It's like this one showing the same property with this one. This one showing the same physical and chemical property with this one. Something like that. So that's what I'm saying. Is that not a trend? It's a trend. So that's the trend. The physical and chemical property. Repeating pattern of physical and chemical property of elements. Arranged in order of increasing atomic number. In order of increasing atomic number. So as the atomic numbers increases in the group or in the period, what happens? Let's find out. Periodicity results from, why does periodicity occur? Why are there this similarity, this repetition, this repeating pattern of physical and chemical properties as atomic number increases or according to atomic number in the periodic table? Why? It's because repeating outer electron configuration. So repeating outer electronic configuration. Some elements have that outermost electronic configuration, especially valence electron. They have repeating one. So this one might have the same valence electron with this one. So that's why you're having the same physical and the same chemical features or properties. So the next we have here under the reason for periodicity is the regular increase in nuclear charge. Okay, the regular increase in nuclear charge. So that regular increase in nuclear charge happens as a result of increasing atomic number in the periodic table, increasing atomic number. So the next we have here is pattern of shell addition down the group. The pattern of shell addition down the group. That's another thing to note. The pattern of shell addition down the group. So how many shell does this element have? That's what is going to determine the group that is going to belong in. In the outermost shell, you see, it's just having just 3. How many electrons in the outermost shell? The valence electron also affect periodicity. Trends in the periodic table. Questions from these are very, very common in WAEC and Jamb UTME. Very, very common. Regular customer. So pay attention. Get your pen and your paper ready. Continue penning down. The first we have here is atomic size. What happens to atomic size? What is the trend? What is the periodicity of the atomic size? Atomic size decreases across the period. That's across. When you hear across, just know it's like this. Period is horizontal, group is vertical. So like this, like this, like this in the periodic table are groups. But period is like this, period 1, like this, period 2, like this, period 3, like this, period 4, and so on and so forth. But group 1, group 2, group 3, and so on and so forth. But when you hear across, just know it's period. So in the period, atomic size decreases as you go across the period. So across like this. The elements here, we have a higher atomic size than the elements here. The next, we have a higher atomic size than the next one, just like that, and so on and so forth. But it increases down the group. Group 1 has a smaller atomic size than group 2. So group 2 atomic size is going to be bigger than group 1 atomic size, just like that, like that. So it increases as you go down the group. As you go down the group, atomic size increases. Remember that as you go down the group, atomic number increases as you go down the group. So as atomic size, it increases as you go down the group. So as you go down the group, atomic size increases. But as you go across the period, atomic size reduces. This one is ionization energy and electron negativity. Ionization energy and electron negativity. What happens to both of them? That across the period, that's as you go through the period, it increases, but down the group, across element down the group, it reduces. This question is very common in Jamb, UTME, and WAEC, so you have to learn it very well. So atomic size decrease down the period, increase down the group, but ionization energy and electron negativity increase across the period and decrease down the group. Metallic character, the state of possessing the property of a metal, it reduces across the period and it increases down the group. So as you go down the group, it increases, but across the period, it decreases. Across the period, as you go across the period, it decreases. But down the group, it increases. Down the group, as you go down the group, it increases. Then electropositivity, that's having a charge of plus, a positive charge. It reduces across the group. Across the group, it reduces. As they go across the group, it go they reduce, they go. Any element you see there, the one where they here, it won't go big past the next one, it won't go big past it across the period. Okay, it reduces across the period, but down the group it increases. Down the group, electropositivity increases. As you go down the group, electropositivity increases. For halogen reactivity, we don't first talk that one now. They treat halogen just now. We talked about that. Okay, that the reactivity of halogens decrease as you go down the group. Reactivity of halogens decreases. So more trends in the periodic table. Alkali metal reactivity, we don't first talk this one now. It increases. Okay, as you go down the group, it increases. The reactivity of alkali metals increases as you go down the group. Then oxidizing power, it also increases across period. It increases across the period as you go across the period like this. Oxidizing power increases. But down the group, as you go down the group, oxidizing power reduces. Cation smaller, anion bigger. So cation are smaller while anion are bigger. You know what cation is? Okay, cation is positively charged ion, but anion is negatively charged ion or no charge. Okay, negative. Cation is positive. Period oxides. Period oxides. They form what? Basic oxide, amphoteric oxide, and acidic oxide. Those are the types of oxides formed across the period. Okay, as you go across period, these are the types of oxides formed: basic, amphoteric, and acidic oxides. Now that we have understood the periodic table and everything about periodic table, periodicity, under 10 minutes, let's now go back to Jamb repeated question 7 that brought us to this topic. The question reads, the group 8 elements are the inert gases because they A. have lone pair of electrons on their valence shell. That's wrong. Remember our discussion about the group 8 elements or the group 0 elements or the group 18 elements, also called the noble gases. So the next option we have here is option D. Are all polyatomic molecules? That's wrong. Very wrong. That's not the answer. In fact, they are monoatomic molecules. They are the group 8 element, the noble gases are monoatomic molecules. That's what they usually form. Then option C says are all solids, which is wrong. They are gases. All of them are gases. Okay, that's why they are called the inert gases. So this option C, is obviously wrong. For your correct option, option B, all have completely filled valence shell. So because they have completely filled valence shell, it makes them stable. It makes them unreactive. Okay, they have achieved an octet state or duplet state of stability. They can't react. It's difficult for them to react. It's difficult for them to take part in a chemical process.